Okay, for probability today, the first day of probability, we're going to talk about contingency tables. So by the end of the hour, you're going to know how to do those. You're going to know how to define probability, some of the key terms in it, and you'll get what experimental versus theoretical probability is. Random. You need to be random to do probability right. I mean, if you're biased, if I were going to pick from you guys and I'm looking at you, it's almost impossible for me to be completely unbiased and pick a random kid. Because something might be catching my eye about you. Maybe it's because you're not paying attention and that makes me want to call on you. Or maybe it's because you're a boy. The teachers have been proven to call on boys more than girls. Is that because they like boys more than girls? Nope. Usually because boys are raising their hand more often than girls. Just the way it is. And at the high school, it might be different than at the middle schools too. But anyway, teachers have also been proven to favor a certain side of the room more than the other. So if I was going to pick somebody, I guarantee you I couldn't do it randomly, even because the stuff in my head that I can't control is forcing me to not do it randomly. All right, so random is actually pretty hard. And don't worry about typing out the exact definition of random. Just kind of listen. In general, you need to know what it is. And if something is random, you can't predict what's going to happen right now. But you can kind of look at trends. Like if I flip a coin, you can't tell me if it's going to be heads or tails, right? But you can know that generally you're going to get about half heads and about half tails. So you can't predict an individual outcome, but you can see kind of trends or patterns. An event is where you actually do something. Like, for instance, you roll this die. Something's got to happen now. So that was an event. All right, so an event for, oops, I had the marker off there. Rolling a 2 on a die. That was an event. Something that happened. All right. Sample space. I bet you most of you don't know what that is. This one's probably worth writing down because a lot of people get this one wrong on the test because they forget what this is. Sample space, the set of possible outcomes of a random process. All the possible outcomes. If I'm rolling a die, do you get there's only certain things can happen? When you actually list all the things that can happen, that's the sample space. Could get a 3. Could get a 6. Okay, and I list out all the things that could happen. So you actually list them. The sample space would include 1, 2, 3, 4, 5, and 6. So if you list all the things that can happen, that's the sample space. All right. Probability, a measure of the likelihood that an event will occur. It's a measure. It's like a scale. We usually say it's between 0 and 1. That's what we have on the bottom here. 0 means can't occur. 1 is guaranteed to occur. But a lot of times people oversimplify this and say, you know, like, oh, for instance, the probability that the sun's going to rise in the morning, that's 100%. Is it really? You sure the sun's going to rise in the morning? Tomorrow? How, you know that? You know the sun's not going to explode tonight. Scientists don't know that. They, in fact, predict that the sun is going to explode. I don't know when. I think it's going to be a billion years from now, but I don't know. So point is that almost anything is not certain. But when you start doing theoretically, like with this die, do you get that my probability of rolling a number between 1 and 6 is pretty much certain? Okay. And on the other hand, the probability of rolling an 8 is pretty much cannot occur. All right, so again, there's a lot of things in life, though. Very, very few things are certain to occur or cannot occur. A lot of things are somewhere in between. Yes? Can you go back to this? Yep. As long as you're not just going to slavishly write down every single word that's on it, because that's not what I need you to do as far as notes. It's understanding it. All right, good. All right. So these are all the things that can happen when you roll 2 dice. You get a 1 and a 2, or a 2 and a 1, or a 1 and a 3, or a 3 and a 1, or a 2 and a 2, or a 1 and a 4, or a 4 and a 1, or a 3 and a 2, or 3 and a 2, or 2 and a 3. It gets confusing to say all of them, but do you get that there's a whole bunch of things that could happen when you roll 2 dice? It's not just you could get a 1. You got 2 dice. Okay, so these are all the things that could happen when you roll 2 dice. What's that an example of? Yes, sir? Sample space is correct. That's what I was looking for. That's the sample space. It's all the things that could happen. What about just picking out one of them and I rolled a, oh, I supposed to have 2 dice. Let's say I rolled a 6 and a 1. That thing that happened, that was called a what? An event. If I do it in a way that I can't predict what's going to happen, then I did it what? Randomly. Okay. Experimental versus theoretical. Theoretically, I should have only a 1 in 6 chance of rolling a 6. But do you get that there are such things as weighted dice? They do really exist. They put little pieces of lead in them so that they are more likely to come up a certain number than normal. Okay? Like, what's a number that people want to come up a lot when they roll 2 dice? A total of, in case you don't know this, 7 is the number you want at the casino. Okay, if you roll a 7 on your first roll, it's called the coming out roll. If you come out and get a 7, you win. Pretty much whatever you bet on, what's called behind the line, that money that you bet, you win. So people love it if you roll a 7 on your first roll. If you roll another 7, you win again. Now, after you roll a number other than 7, let's say you come out with a 2 and a 3, so you got a 5. All right. Now that you rolled that number, now whenever you roll a 7 after you can establish the point number, then if you roll a 7, then the house wins. So the only time it's good for you to roll a 7 is on the first roll. After that, after the first roll, then if there's another 7 rolled, then you lose automatically, whatever's behind the line. So the house wins a lot on people rolling, sorry, yeah, the house wins, not the casino. The casino wins if you roll a 7, except for on the first roll. So they got it set up so that they're, of course, more likely to win. It makes sense. Casinos win lots of money. That's how they can build gigantic casinos. All right. Now, my point here is, what's theoretically what are you supposed to get when you roll 2 dice? Well, that's that chart. This is theoretically the probabilities of rolling these different things. And 7 is the one that's most likely. But when you actually do an experiment with the dice, could you find out that the dice were coming up 7 way too often? Yeah, because they could be loaded dice. So the point is that theoretical is what's supposed to happen. Experimental probability is what actually happens when you do an experiment. That's the point you're trying to get here. Don't get absorbed in the words too much that you're reading on the screen there. Just make sure you understand theoretically is what's supposed to happen. Experimentally is what actually happens when you do an experiment. So say I have a coin. Do you get that it's supposed to come up heads half the time? What happens if I flip the coin 1,000 times and it comes up 600 times heads and 400 times tails? Do you get when if there was that many trials, like you do it 1,000 times, something's probably wrong with the coin? There are weighted coins too. Harder though. Yes, if you're not being random about how you flip it, if you're defining like, okay, if I hold it right here and I flip it with exactly this amount of force, I can get it to come up heads more often. You're right. You can throw it off but that is assuming you've changed it to not random anymore. Okay, so experiment is what happens when you actually do an experiment with the coin or with the die, and theoretically is just what it's supposed to do. All right. Contingency tables. This table right here is a list of males and females and left-handed and right-handed and the totals. It's all just nicely organized. All right? I'm curious, how many in here are left-handed? Raise your hand if you're a lefty. All right. And ironically, you raised your right hand. Okay. Only one lefty in here. In this poll, how many people that you see on the board here were polled? It's easy to find. What is it? 100. How many were male? 52. So what's the probability that if I grab somebody out of the survey that they would have been male? 52 out of 100, which would be 52%, about half. Okay. How many female? 48. It's too easy. What's the probability a person polled was left-handed? Okay. A person polled. Do you get that all the people were polled? So that was out of 100. The left-handed ones were 13. I can't pick the 9 or the 4 because I'd only be picking males or females. I got to pick the total. So 13 out of 100. They're not all this easy, believe me. Probability gets much more complicated. We're starting with the easiest stuff, of course. It's getting close to lunchtime, but it's not quite lunchtime yet. What's the probability the person polled was female? Well, wait. The person polled, is it talking about this question? Because then that would change my probability a lot. Because if it was, we know the person was left-handed, and now we're trying to figure out if they're female? That would make the problem much harder. So you got to read these carefully. I can tell you that this is a new question. It's not talking about this previous question. So then if it's just a new question, what is the probability that the person polled was female? Because there's 48 females out of 100, so 48 out of 100. Now just think for a second. If I was talking about this previous question where I got a lefty, and then they said, what's the probability they were female? Now do you get I have to only look at the lefties? Because they said we got a lefty. If they said we got a lefty, then it would only be talking about this, not these. None of these numbers matter. It's only the left-handed people. And if we got a left-handed person, then they were saying, what's the probability they were female? Then it would be 4 out of 13. Do you get the 4 out of 13 number, where that would come from? That's assuming that we knew that they were going to pick a lefty. That's called a given question. That's where these can get more complicated. And it changes the problem because it's not out of 100 anymore. The denominator won't be out of 100. It'll be out of something smaller. All right, this next one. See if it's an easy or a hard one. Randomly chosen male is right-handed. I want you to take your best guess on what the answer to this is. Write it as a fraction because I know you don't have calculators and I don't want you to bother to get them out. And write it on your paper, and then I'll tell you what the right answer is. If you have an iPad and you're doing this with an iPad, you could write the answer down, and then I could, that's one thing I could do that would be cool right now is if you all had your iPad, you could write it down, zoom in on it, and then I could go right. I could see your answers from across the room. It's kind of nice. But want to try it once? Write down what you think the answer is. Zoom in on it, and then turn it my way. All right, awesome. See, I can see what she thinks. All right, what do you think? I got it yet? Okay, go ahead, try it and turn it my way in a minute. All right, I don't want to put you on the spot personally, so I'll just move on. Randomly chosen male. Did I pick from everybody? Did I pick out of 100? No, I did not. Randomly chosen male means I picked from the men. Do you get that the whole rest of this chart then is irrelevant? I picked from the men. So now it's out of 52. And what was the thing I wanted? I wanted a right-handed. So that's what I want over what's possible. Probability is what you want over what's possible. If I were to give you a simple definition, that would be it. All right, lunchtime, go. Go. Okay, we're back from lunch. So, what is the probability that a person is left-handed, given the person is female? Well, if they're female, then I have to ignore everything on that chart except the female category. As soon as they say, given that they are female, you have to go, okay, only talking these numbers. If you find yourself using any of the other numbers, you are doing it wrong. You can't take it out of 100, for instance. You got to take it out of 48. And then you can only use this or this for on top. Now, do you know when to add them or when to subtract them or when to whatever? There's and or. Yes, sir?
Would a 950 not only 52?
Yes, sir.
43?
Okay, I'm not sure anymore what that was from, but let me check. So we're going to go, he's asking me to go back a question. We're going back to this one on number 5. What is the probability randomly chosen male is right-handed? You are correct. So thank you for clarifying that. It was right-handed males, so that was 43. Okay. I was talking about lefties the whole time, and then all of a sudden the question was about righties. All right, sorry about that. Back to number 6. So this is about left-handed people. So if I'm looking for lefties, remember, if I can only take from the females, I got to take from this. I can't use any of these numbers. Now, what do I win if I get a what? A left-handed person. And the left-handed is here, so I go 4 out of 48. Raise your hand if you understood that. Okay, good. The key is going to be reading the question carefully. Let me read you, for example, a question off of today's homework that could be confusing. Find the probability that, okay, that part's easy, a randomly chosen person whose highest level of education is high school is a man. So the wording can be confusing on that. I'm going to say it again. Find the probability that a randomly chosen person whose highest level of education is high school is a man. All right, so were they trying to say given that blah, blah, blah? Yeah, they were. They were trying to say given that the person chosen, their highest level of education was high school. All right, now I'm going to get these worksheets out to you. I'm going to pause for a second while I do that. Okay, I'm going to help you on the worksheet number 1, part D. A lot of people ask about that one. Get there. I know you aren't to it yet, but maybe you are. Number 1, D. The probability that a randomly chosen person whose highest level of education is high school is a man. Am I picking from anybody in the survey? No, I'm only picking from people whose highest, no, it doesn't say that you're picking from only men. They want to know the probability it's going to be a man. So they're saying you can only pick from, like, the things that are possible. Remember how I said it's what you want over what's possible? The possible things go on the bottom. The only things that are possible are the people that have the highest level of education is high school. So where is that one? High school graduate. And you read across, and the numbers there are women 232, men 305, and total 537. So that's the one we want, where the high school graduate is their highest level. So if I'm allowed to pick from anybody in that category, then that's the total. So that's what's on the bottom. What's on the top is what you want to get. We want to get a man. Now, how many are there that are men? That one. There's how to do 1D as in donkey. There are a few more tricky ones down there, like given ones, like 2E as an elephant. 2E is another given one. You might want to underline the word given, because that means you only narrow it down to a certain part of the chart. Yes?
Should we leave them in fraction form?
Good question. The directions say round all answers to 3 decimal places. So no, if you have fractions on yours, you're going to get them marked half off each time. So I would recommend you grab a calculator, you take them and you divide them, and if you get an answer that comes out to like 0.4167, that you'd round that to 0.417. We want 3 decimal places like that. That's the way probabilities are usually done, is with decimals. I mean, a lot of times in the real world you hear about fractions, but when you have a real question on a test, it usually has a decimal answer. Good question. Thanks for asking about that. Okay, so now you have a whole bunch of time to work on the worksheet called 12.1 Worksheet A. And yeah, I hope by the time you're done, you're going to say that was pretty easy. This is supposed to be the easy stuff. We will get into hard stuff on probability, believe me.